So let me turn my tablet on. Okay. I got a little careless on this one too. I didn't mark which ones people were having trouble with. So I think we did okay with number 1. Again, you should be copying these down and make sure, at least the answers. You could even potentially take a picture of the screen with your phone if you need to take some notes on something to go back with, or your parents' phone, or whatever. I think we did okay with number 2. Any questions on number 2? I can't remember. Okay, we're just using the fact that, the mid segment is 1/2 the length of the side opposite. So BD is half the length of AE. All right. And that also means that uh, 2 times BD is equal to AE. So what are we asking here? Solve for x given that BD is 3x plus 3 and AE is 4x plus 8. Okay. So we need to take either one of these formulas, so to speak, and plug in what we know and then solve. All right. Number 3 is A. Move my chat box here. All right, Jonathan, I'm going to mute you. Your sound was on. All right, so if line KF is the perpendicular bisector, also just, I didn't read it carefully enough to see if it mattered in the context, but some of you were putting bisector when it would have been angle bisector or perpendicular bisector. So just make sure that, that the reader knows what you're talking about, that you either spell it out or the context makes it clear. All right, so KF is a perpendicular bisector of segment GH, then angle KGF is congruent to angle KHF, okay? If it's a perpendicular bisector, we know by, either angle or, by side angle side that the triangles are congruent. Okay, if it, F's a midpoint, then HF is congruent to GF, and actually side, 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 and then this side's, so side, side, side says that that all the sides are congruent. All right, or the triangles are congruent, therefore these corresponding angles are congruent. All right, and I stated that differently than what we see here. Okay, so there's different ways we can look at that. Okay, so more vocabulary is involved in this one. You need to memorize these different parts and these different points of concurrency that we're talking about. So the perpendicular bisectors of a triangle all pass through what point? I think I had some people say segment or mid-segment or something. So this is vocabulary. Okay, number 5 is B. Again, I messed up. I didn't note which ones people were missing, so I don't know which ones to slow down on. So if I go past one that you have a question on, please speak up. So that's number 5. Number 6, which side lengths allow you to construct a triangle? Okay, so the sum of 2 sides has to be greater than the third. So I need to check all the possibilities and see if, is 6 plus 8 greater than 10? Yes. Is 8 plus 10 greater than 6? Yes. Is 6 plus 10 greater than 8? Yes. So these three sides can make a triangle. All right, good. Thanks for giving me a heads up there, Jake. Okay, so number 7, two sides of a triangle have lengths of 7 and 13. The third side has a length of what? So remember, we can determine the range, the possible range of lengths for a triangle if we know two sides, because that unknown side length has to be less than the sum of the other two sides and greater than the difference of the two. Okay, so the largest angle is going to be opposite the longest side. So 11 AB is the longest side. Oh, just lost my chat box. So this is this is kind of like a formula in a sense when you're finding the range of values for a third length of a third side of a triangle. Remember that unknown side is going to be greater than the sum of the other two and less than the difference of the known two. Okay, is it possible for a triangle to have sides with the given lengths, 19, 13, and 14? So it's important that you guys pay attention to these. You didn't do an assignment on practicing these. So is it possible for a triangle to have sides with those given side lengths? Well, again, we got to check all the possible combinations of the sum of two, make sure they're greater than that third. And yes, the sum of each of the two possibilities is greater than the remaining third side. Okay, which statement is false for the diagram? And that would be I. Okay, so here's Ln, and here's NP. All right. Since the key here is that the fact that these two sides are congruent. Okay, and these two sides are congruent. All right, and so since that's the case, then the longer side is going to be opposite the largest, the larger the two angles, and angle R is larger. So actually NP is greater than Ln. Okay. Now again, the key, and I didn't mention this in the lesson, but the key here in this one is the fact that these, these corresponding sides are congruent. If Lm was longer or something like that, we would have a different situation. So we couldn't compare Ln and Pn unless we knew that Lm and Nm were congruent to, Rp and Rn. All right, so Jake said he might have a question on number 12. Find the value of x. Okay. It looks like an equilateral triangle. All right, but we can't assume that it is. Okay, if it's an equilateral triangle, then I know that these sides are congruent, or an isosceles. I know these sides are congruent, so those two expressions have to equal each other. But grab my pen here. We've got a perpendicular bisector here, and then so here, here's some point here. Okay, and then this is a right angle. So by side angle side, side angle side, side angle side, I know that these two triangles are congruent. That means, this side's congruent to this side. So 3x is equal to 5x minus 20. This is an isosceles triangle. These two sides are corresponding sides of congruent triangles. And Oh, okay, yeah. I thought the directions said for you to just or tell how you knew it or something like that. I don't know. Maybe I need to go back and adjust on that one. I don't have the test up. Does anybody have the test up? Didn't it say to justify or something? Anybody have the test with them? What does it say? It just says find X. Okay, I'll have to go back and look at that. Okay, so you actually got it right, Jake, is what you're saying? You put, okay, all right. Y'all help me to remember that to go back and look. Okay, so this is -10. No, because right here on this step, like, okay, so I want to get X on one side of the equation, you know, all by itself. So I'm going to subtract 2X on both sides here. And so that would give me -2X is equal to -20. So negative divided by negative is positive, so X is equal to 10. And right, and so what Jake is saying is if he checks it 3 times, -10 would be -30, and you don't have a negative side length. Yeah, if you put X equals 10, you got it right. And I think was that Andrew that asked that question? I think Andrew, I think you had -X is equal to -10, which is a true statement, which is correct, but we don't leave a variable negative. We multiply both sides by -1, so it would be X is equal to 10. When I multiply negative times negative, that's positive. Negative times negative, that's positive. So yeah, if I marked half off on any of you guys for not justifying, I'll go back. All right, so these are knowledge-based questions, and you need to know these for the test. Okay, so that's for the mid-segment theorem, parallel and half. Okay, so for a perpendicular bisector, any point on the perpendicular bisector is equidistant from the sides. So that means CA would equal CB. And then if you find that a point is equidistant from the endpoints of a line segment, then you know that the point's on the perpendicular bisector. All right, so we need to know that, okay, the perpendicular bisectors form the circumcenter. The circumcenter is equidistant from the vertices. Okay, so that's why we can circumscribe it. So PA, PB, and PC are all equal in length. Okay, so a point on the angle bisector is equidistant from the sides. And then we also know it's true that if we find a point on that is equidistant from the sides of an angle, then it must be on the angle bisector. All right, so for the end, for angle bisectors, they intersect at the point of concurrency called the incenter, and it's equidistant from the sides of the triangle. So what's unique about the medians of a triangle? Remember, the medians go from the midpoint to the opposite vertex. And here's a key, possibly, as far as when you're taking the test, you got to do this by memory. Just remember as far as filling in these blanks, just remember the concept. From the vertex to the centroid, it's 2/3 the length of the whole median. Okay, so if you have AP, that's the segment, then it's got to be 2/3 of the entire median. Okay, so the only thing we can really say about the altitudes is that, of a triangle, they are concurrent. Remember, we saw that the point of concurrency for altitudes could actually be outside of the triangle if it's an obtuse triangle, and same thing with the circumcenter. So the circumcenter, and then this is, remember, called the orthocenter, they can both be outside of the triangle for obtuse triangles. All right, so make sure you practice this. Make sure you're able to identify what the point is. So for number 22, I can look and see, okay, DH and EJ and FI, I should be able to recognize those as perpendicular bisectors because I have right angles, and then I've got congruent marks. D is a midpoint. So I need to recognize DH, JE, and IF, they're perpendicular bisectors. And if that's the case, then the perpendicular bisectors meet at a point called the circumcenter. So I should be able to recognize CE and BL and AF and so forth as angle bisectors because of these congruent marks. Okay. And so then I know, okay, angle bisectors intersect at the point that's called the end center. Okay. Again, vocabulary, I should recognize these as medians because, congruent marks, F is a midpoint, and it goes to the vertex. That's what a median does. And so the intersection of medians is called the centroid. And then I should recognize these segments as altitudes because they are perpendicular to the sides and they go to the vertex. But notice they're not necessarily, D is not a midpoint, E is not a midpoint. So they're not, I don't confuse those with perpendicular bisectors. Yes, they have right angles like a perpendicular bisector, but they're not necessarily at midpoint. So I recognize these as altitudes, and altitudes intersect at the orthocenter. I'm looking, this is my last portion, and I don't have I don't have 29 and 30 on here. So you guys, some of you stumbled on these equations. Take a look at this. I'm not going to go through it all unless you have a question. Just take a look at it. But so this will not be on the Chapter 5 test, but it will be on the semester exam. Okay. So Jake's asking, where is the video on these? This is from Chapter 3. Okay. This is what we practiced from Chapter 3. So I was just having you retrieve some prior knowledge. So again, this will not be on the Chapter 5 test. I better double check. I don't think it's on there. But you do need to be able to do this for the semester exam. So take a look at those and see if you have any questions on those. All right, let me see if I can figure out how to pull up. I don't have 29 and 30 on here. Bummer. Let's see here. So 26 and 27, I'm using y equals mx b for both of them. Mx plus b, we're just solving for m and b. And number 27, uh, the line that contains this point -0 is going to be perpendicular to the line in this equation. So my slopes are going to be opposite reciprocals. The slope of this line is 3/5. So, all right, let me see if I can figure out. Okay, so that's number 29. All right, number 29, you should be able to make sense of this when you look at it, you look at your results on the submission. I'm just trying to reinforce the idea of, get you to put different information together that you've learned. And I'm trying to reinforce that, for a median, that notice this is an isosceles triangle. The 28 was x equals 4. Okay, so we've got the point 4, -6, and we want a line that's perpendicular to y equals, here's y equals -3. We want a line perpendicular to that contains the point 4, -6. So a vertical line is going to be perpendicular to horizontal, and x equals 4 is going to contain 4, -6. Okay, the thing that I was trying to reinforce, you're not going to have to do anything like this on the test. Again, I got to make sure I took that off, but I'm not planning on you having to do anything like this on the test. What I'm trying to reinforce is what you see on number 30, that for an isosceles triangle, the median is also going to be an altitude, a perpendicular bisector, and a angle bisector. Okay, so I don't have number 30 up here, but I covered that in the last section, or the last video of 5.4. So what you need to remember is what you're seeing there for number 30. Again, I don't have it for you, but the answer is that, this line segment AD is a median, it's an altitude, it's an angle bisector, and it's a perpendicular bisector. Okay, so that's something that we're going to use later on in the year, that knowledge. Okay. All right, so that is all I have. So I will send out a link, probably go ahead and make that link right now after we get off here, as far as going over the semester exam practice test tomorrow. All right. Any questions or comments for the good of the cause? All righty, so I will end this meeting, and we'll be seeing or hearing from you tomorrow.